So in this problem, we need to determine the equation of a parabola with focus at the origin, and the equation of the directrix is given to us. Let us begin. So here what we'll do, let's try to understand this problem graphically. We'll begin by considering a straight line. So this is a vertical line. Let's say this is the directrix whose equation is given as 3x minus 4y plus 2 equals to 0. Now, we're going to consider another line which is perpendicular to this directrix. Now, by definition, on this line, we have a focus F with the coordinate 0, 0. This point is the focus, and we have to determine the equation of the parabola. Now, to find out the equation of the parabola, we'll consider a point P on this plane. That's P, let's say its coordinates are h, k. This is the locus of a point P. Now, we have to determine the equation of the parabola. What we'll do, we're going to join the point P and the point F, which is the focus. And then we're going to drop a perpendicular from point P on the directrix. So let's say the perpendicular meets the directrix at M. So here, by definition, for a parabola, we know that the length of PF is always equals to the length of PM. Now, we can easily find out the length of PF that can be obtained by using the distance formula. We'll take the square root. Underneath the square root, what we'll do, we'll first take the difference of the x coordinate. So that's h minus 0. We square it and then add it to the square of the difference of the y coordinate. So we have k minus 0 whole square. This will be equals to PM. So we have PM. Now, to find out the perpendicular distance, we will be using a formula. So we'll take the absolute value. So inside the absolute value, we have a ratio. So here what we'll do, we'll take the x coordinate of point P and multiply it with the coefficient of x of the directrix. So that will be 3. So we're 3 times h. Add it to, now we will take the y coordinate of point P. So that's k. K gets multiplied to the coefficient of y. So that's negative 4. Added to it will be the constant term, that's 2. And we're going to divide it by the square root of the sum of the squares of the coefficient of x and y. So we'll take the square of 3 and add it to the square of negative 4. Now we'll need to solve this. So here we have the square root of h squared plus k squared. This will be equals to, we have absolute value of 3h minus 4k plus 2 whole divided by 5. Now, we'll square both sides. Squaring both sides gives us h squared plus k squared. That will be equals to 3h minus 4k plus 2 whole squared divided by 25. Cross multiply, we get 25h squared plus 25k squared. That will be equals to, now we need to square 3h minus 4k plus 2. So that's 9h squared plus 16k squared plus 4. Then we have negative 24h comma k minus 16k, and we have 12h. So what we'll do, we'll combine the like terms. So 12h squared minus 9h squared, that will be 16h squared. Then we have 25k squared minus 16k squared, that will be 9k squared. Then we have negative 24hk, that becomes positive 24hk. Plus 16k and minus 12h and negative 4 equals to 0. We're almost done. Since we need to find out the equation of the parabola, finally what we'll do, we'll replace the value of h with x and the value of k with y. So that gives us 16x squared plus 9y squared plus 24xy. Then we have positive 16y minus 12x minus 4 equals to 0. And this is going to be the required equation of the parabola whose focus is at the point 0, 0. And the equation of the directrix is given by 3x minus 4y plus 2 equals to 0. We can use a standard graphing calculator to graph the parabola. So let's look at the graph of the parabola. So here we have the parabola. So this is the blue line is going to be the directrix line, and the focus will be at the origin. We have already, it was given to us that this is at the origin. This is the point of the focus. So this is how the graph of the parabola 16x squared plus 9y squared plus 24xy plus 16y minus 12x minus 4 equals to 0 looks like.